Welcome to today's video where I have a bit of a mess behind me, but we're going to be talking about getting started in a J1850 or GM Class 2 project here. So it's going to be like communicating with a module in a vehicle or getting data from a module in a vehicle. So yeah, this will be kind of like a how-to guide to get started on one of these kind of projects. Maybe you want to data log something, or you want to make your own gauge pod, something of that nature. So in this video, we're going to do some of the basics here. We'll look at how to read, how to write on Arduino using a module that I sell, which is this guy. At the heart of it, it's just a XC68HC58 with a little boost power supply on there. Pretty simple circuit. And then I'll also show some Elm 327, which I may not actually use any of the Elm 327 devices, but I will use the OBDX Pro here. It's a little bit different than an Elm 327. He's kind of emulating that inside here, but it responds to the same commands, but it also has its own command set as well. So we'll use the Elm 327 commands on here. I've tested it before. They work exactly the same. I just don't want to have to switch between modules. Yeah, I'll have links on some of these cheaper Elm 327 devices, a link for the OBD, and the link for my product. This one, I'll be showing you how to use it with Arduino. So here's a kind of a better view of what's going on the bench. We have an Arduino Uno with one of my modules that we'll do some writing with. We have a Pro Micro with another one. This is the older Rev B of the same module that we will do some reading examples with. There is the PCM here. We have a switch that's on the ignition and the cruise control. And then we have a potentiometer here that's the fuel level. And these exposed wires, which we might get into, are the park reverse neutral switch. I've had a couple of customers recently that had difficulty getting started on their project, and were even questioning if I tested them, which I have a video on how I test these before I ship them. They all get tested exactly the same. I test that they can read and write. One of them even sent me some of the example code that they were testing with, that they had changed some of the stuff in, and I thought that my example codes were bad because of what they had, but the example codes I had were right. But I just wanted to show a little more detail on these things working, but also kind of show how you could get started on one of these projects with something like this. Some of the requests I've had for stuff to do with these, it really would have just made sense to get like an OBDX Pro, because they were trying to do some sort of like troubleshooting of the car. And, you know, for the price, you might as well spend the money on a ready-made tool than try to make your own tool for data logging. But, you know, I do have some firmware that I'll show on this that can do data logging. Okay, first let's talk about like what device you should use for your project, like what's right for you. So here's an example. You want to make a instrument cluster that's using an old tablet like this, maybe with a little less busted of a screen on it. But yeah, you have an old iPad, for example, or a old cell phone that you want to use that nice display that it has to be your screen for your car. Maybe it's a race car, something off-road, I don't know. It's just an example. You may want to just consider using, you know, one of your Elm 327 devices. You know, you connect to it via Bluetooth, and then it's just a serial port that you're talking to. It's a pretty simple way of completing one of these projects. You may have concerns about the reliability of the Bluetooth, but it tends to be a pretty reliable protocol. But if you are concerned with that, you can always use, you know, the OBDX Pro, which has a USB port on it, and then that USB port shows up as a serial port. And again, you can just talk to it that way. Another computer option that you might end up with is the Raspberry Pi, which these again will support your USB for this device here. and you should be able to get Bluetooth dongles to be able to use either of these devices, and some of them even will run off of Wi-Fi. Another example where you would probably just want to use an off-the-shelf tool is if you're trying to data log. Again, it's as simple as, you know, opening up the serial port and data logging. You don't have to use any fancy apps or something, so you can just hook this up to your laptop, open PuTTY, and send a couple of commands and you'll be data logging. I'm going to show that here in just a moment. So another likely scenario is you might want to make a custom gauge pod like this, or one that's using an LCD. It's just a single pod and you don't want to have Bluetooth and stuff running. You just have your microcontroller and just wire it up. So that's an example where you may want this to come into play, where the little module that I sell, you can hook it up to an Arduino and you'll be able to control it. So this may be something where you want it to be a little more discrete on its location or how it's working. You can use that and, you know, should tuck it up in instead of hooked up to the OBD port all the time. Because that's one of the disadvantages you have of these, is you now don't have an OBD port anymore unless you put a extension in there and wire in a second port, something like that. So yeah, you may want something more like this, where you're capable of maybe hiding it in there if you're doing like a conversion from one type of data to another. You may not want to use these. All right, so real quick, if you are going to go with the module that I sell, definitely check out this. But some of the information I'm about to show you will also apply to these as well. So on my GitHub, you'll find this repository, and it has some things in here like the board files if you wanted to make the little modules that I sell. Those purple ones are Rev A. And then so there's Rev B, which is the red one you see in the background, and Rev C, which is the black one. And then I have some different example codes on here. We'll take a look at this one that I just recently uploaded here in just a moment. And then we have the write example, which has been there for a while, and the read example. I did update the read and write example to make them run a little bit faster. But other than that, they stayed the same over time. And then there is this firmware here, which works with the program that I have on my GitHub as well. That this one is using the Pro Micro back there. It'll allow you to data log as if it's one of these. Again, for data logging, I really do recommend, you know, something like this. But if you just so happen to already have one of my modules and you want to do data logging, you can do this. I will admit my Windows form that I made is a little bit buggy because I'm not a programmer. I just did the best I could, but I will show this. Okay, so here's a quick scenario that we will kind of go into how to do. Is let's say you have a aftermarket PCM in your Silverado that can't control the instrument cluster. Let's say you have a Speeduino in there, or you did an engine swap, and so you have one data type that you need to convert to the other data type. So say you have a Ford engine with its communication protocol and you need to speak to this. So we're gonna assume we know all of our variables from the other one, and we just need to write them to the instrument cluster. So basically we have this interior with no GM PCM in there. So we're going to be just simulating data for it. So I have this cluster scenario here, and it will be able to control any of these gauges, any of your lights, but it cannot control these two gauges because these instrument clusters, they respond to pulses on here. Now, that is still something you can control with an Arduino. You do have to you need a variable frequency on them, not a variable duty cycle. So you're not going to be using your PWM pin off of the microcontroller. You would just use a variable frequency square wave. We have this instrument cluster. We want to control the J1850 stuff. and so let's get right into that. It's very similar to my old write example that I had, where it defines some pins, brings it up, and we reset transceiver, and then we do the initial setup, and then we can start sending frames to this. So this frame is going to set the voltage on the display to about 14 volts there, and that one comes from the BCM. And then we're going to set the coolant, the oil, and the fuel level with an iteration here. So these I1 and I2, you would just use your data that you already know you need to send to it. But yeah, these three frames right here are different values, which again, you can find some of the known frames that I have figured out in here under frames. In here are the frames that I've figured out. So yeah, then we have these two frames right here that the instrument cluster wants. The top one is a kind of keep alive frame from the PCM, and the other one is from the BCM. Basically, it tells it any of these registers that are set, you can just keep that data, I'm happy. So if you don't send those frames, you have to re-update that every like 2 seconds or so. All right, so just to get an idea here, you set the voltage, and then we're iterating through oil pressure, fuel level, and coolant. These two are sharing the same variable. That one is a different variable. This one's range is not the full 0, 0 through FF, but I went ahead and just used that. Yeah, so this is a scenario where you may want to use like my module that I sell, because you're wanting to control something continuously, and you may have multiple sources of data that you need to work through. So I think this is a pretty good example to show that the module will work for writing to a system that you want to write to. Let's take a quick look at reading with the module, and then we'll take a look at using an ELM 327 device. So real quick to show reading, we'll use the example program that I have for doing a little bit of data logging. Again, this program's not perfect, but it will get you started. So we're going to connect to this Pro Micro, and we're going to put it in RX mode, and we will start to see some data coming across. So now we can see the data, and again, this data is all coming from this device right now. We don't have any power applied to the PCM. And just to show that it can data log from the PCM, that it's not just my two devices will talk to each other, hook up the PCM to it real quick. And now all of that data coming across the bus is actually coming from the PCM itself. All right, and just to show something that was not included in my program so you can see any tricks, let's go ahead and show something on the park reverse neutral by shorting some of these wires together. So there we go, we got neutral. And then we can turn up the potentiometer for the fuel and get some fuel readings there, which is how I was able to figure out a lot of these different frames that I showed in the folder. So definitely refer to that folder. So that was the basics of reading the bus here, that we were using the Rev B board, which works the same as the Rev C. I just changed some components on there and placement, but they're pretty much the same board. But yeah, the Uno is disconnected. The module was reading from the PCM itself and getting the communication between these two devices, and we were just reading what was on the bus. This was able to write to the bus and control it. So let's get a really quick understanding of how this read function works, because it's not quite as straightforward as you might think. I'm not going to go into too much detail on how to read, just because you can make a full video on that. But the very basics you need to understand is that there is a status byte, and the received data buffer, which would also contain your CCRB if that's what you're looking at. Status byte tells you what you are looking at, what's in the data. Is it the first byte of the frame? Is it just a byte and there's a continuation byte? Is it the end of the frame? So are you really looking at a CCRB? So the completion code. The way you're going to deal with this is, so in my example here, I'm not handling the status byte very much. The main thing I'm looking for is this status byte valid? And is there, if so, then send it to the computer and the computer handles the rest of it. So the Arduino code that's running on here is not handling too much of the status bytes. It's just going, hey, is this valid? Okay, here you go, computer, you deal with this information. And then the computer's putting that together as a full frame. So you're not receiving an entire frame from the module at one time. You're receiving a single byte. So you need to know your status, and then you need to know what is this byte that I'm looking at? Is it data? Is it valid data? Or is this a completion code? And so you'll refer to the data sheet. That way you have an understanding of where to look at in here. But first, you're going to want to refer to page 418 and 419 on how to read. It'll give you a good understanding of the block diagram of actually reading from the buffer. There are a couple of important things you need to know. You need to know your command that you're going to send to read it. So what to do. You're mostly for reading, you're going to be dealing with the RFC commands, which are those 2 bytes. So with your RFC command, you can say, do nothing, 0-1's reserved, it doesn't use anything. Then you can flush byte or completion code, or flush frame except for completion code. So this one is what you actually see me sending over and over again in that example code. The next thing you need to understand is your status byte. So the status byte, you'll get all your information on that starting on page 5.9. So your status byte, your RFC really tells you what you're dealing with here. Like, is it invalid data or good data? That's the really important one you're going to look at. That DLI, the main thing you want to make sure of on it is that it's not always high. If it's always high every single time you're looking at it and you're not getting valid data, you probably have a short on that line. And the last thing you're going to want to know about is your CCRB. Best case scenario, you're going to get all zeros across the board here. Everything's good, everything's happy. And also the CCRB is why you don't get a CRC at the end. It actually just checks the CRC and it'll tell you that there was an error. So CRC you'll find here in the error code field. Basically, if you had a CRC error, if you had incomplete byte, if you had a timing error. So those are really your important ones. So again, in Arduino, the way I read it, so when I'm sending it is this dummy byte, which is 00. You could send anything as your dummy byte. And then I send 02, and that 02 is telling it to flush the byte. So then as it does that cycle, you're going to get a status byte in your received data. Received data is also CCRB though. So you have to look at what that status byte is and see, is this the first frame? Is this just a continuation frame? Is it the end? And then you're going to want to know if you are looking at a CCRB to handle that as well. So yeah, that kind of covers how to read the buffer with this. The main thing you need to understand with this is you're going to have to refer to the datasheet for more information, and that you're not just going to get like you're not going to send it a byte and then just receive a whole frame back. You're going to read the buffer and reconstruct it into a frame yourself. Okay, so now I have the OBDX Pro hooked up. Let's talk to it over its COM port and see how we can receive data with it. So first we need to use, I'm going to use PuTTY, but you can use whatever serial manager you want, or you can use one of the tools that you download for it. So with this, we're going to use COM port 10 is what it's showing up as on my computer. This may vary for you. You open your COM port, and you have a few commands you need to send it. I always first just send the reset command. It just resets like the headers that it's looking at for this one. ATAR. Then we're going to have ATSP2. And that set it to J1850 mode, which this particular version of the OBD link, that's the only one it supports. And then we're going to have ATL1, and then we're going to have ATH1, which that's set enabling the longer frames and setting the header length, if I remember correctly, and then ATMA, which is going to just monitor. So now we've sent all the commands to get it into data logging mode, and this is all of that data coming out of the Arduino again. So I have the Arduino set up there, and we can just hit like Control C and stop reading. So that allowed me to do data logging very quickly, very easily. I didn't have to write any custom code. And if you were wondering where I got all of those commands that I was sending it, some of that's from experience of just using these type of devices in the past, but you can always just refer to the user manual. So Pete has a user manual for this on his website. So you just download the user manual, go through it, and it has all of the commands it responds to. And again, this device is not actually one of those ELM 327s or ELM 327s. So yeah, it has the ELM commands that it supports, but it also has its own custom commands as well once you get past that. So you can change the mode that it's running in. One of the things you'll notice in the buffer here is there was that extra character on the end compared to what I was sending. That extra character at the end there is the CRC. So instead of getting a status bit, which was 00 pretty much every single time we were reading it with my device, with this device, you'll get your CRC at the end. So that's kind of the main difference you might see. As you saw, that was really easy to do to get into data logging, and there's a nice reference manual for it. And so again, even this device here, when you connect to it over Bluetooth, it is a serial port over Bluetooth. So it's the exact same way of handling it. You can, if you're using a laptop like this, you can just use PuTTY and read it like that, or you can make your own script. And so yeah, I mean, that kind of example there would very quickly turn something like this into a display. You can set a filter on these devices, so that way you're only looking for a particular frame or particular header, making it easier for you to do this as well. So you can just have it already flush everything other than that one single thing you were looking for, making it much easier to do your project. So again, there's pros and cons to doing this. Like this is going to be a lot of low-level programming you're going to have to do to get your project up and running. So something like this might be easier. So if your project is like a computer or a tablet and not just a microcontroller, then this device would probably work better for you. But again, using something like this, this microcontroller has Bluetooth, so you could still use one of these on your microcontroller project, like the Arduino Nano 33. So yeah, there are options for these kind of projects. Okay, well, I hope this video has helped you decide on how to get started on your project. If you want to use one of these type of devices or one of the modules that I sell. And I know I keep saying this with an Arduino, it's really any microcontroller that supports SPI. Even if it's a 3.3 volt, you can just use a level shifter with it. It is a 5 volt module. Yeah, it makes the 14 volts that it needs on there. But again, if you have like a computer system or a Bluetooth connection, one of these will probably get the job done for you, and it may be quicker and easier to get your project up and running going that route. So I definitely want to show that there are other options other than what I'm selling, and if you want to support me, there's links down in the description. I do highly recommend Pete's product that he sells. It's been consistent and reliable, while these guys can be very inconsistent from different manufacturers or even the same manufacturer over time. So I definitely hope this video helps you get started on your project, helps you get a better understanding of how the project works, and for anybody that's bought one of my modules, might help you understand better how to use it. So yeah, I hope you guys liked the video, and I will see you guys in the next one.